Question 3. Okay, straight into the analytical geometry. That's normally the process, guys. Question 1 and 2, statistics. Question 3 and 4, analytical geometry. And that is how it's going to go on. Okay, so in the figure, L is that, S is that, N is that, are the vertices of a triangle having SLN equal to 90. So that 90 tells us we're dealing with a right angle triangle. We also know that SL and LN are perpendicular. Cool. So 3.1, let's give it a go. So yes, you do get certain formulas. So you'll get your distance formula, you'll get your midpoint formula, all on the formula sheet. But I'll repeat it again. If you need formula sheet, you haven't practiced enough, okay? So calculate the length of SL. Let's do it. So SL, we are looking at those two coordinates. So SL's length is equal to the square root of x2 minus x1, so 4 plus 4 squared plus 5 minus 1 squared. And we'll put that into our calculator straight. I wouldn't advise using mental math here because there's always room for error, so just put this straight into your calculator. And the answer the calculator gives is 4 root 5 units. Okay, something that I picked up now, my calculator was still in stat mode, so just remember to put it back into comp mode. So just press mode on your calculator and press the number 1 for comp mode, so normal mode. Cool. Let's move on to 3.2. Just before I move on, 3.1, 4 root 5 units. Remember, a distance is a unit of measure, so you would have to say 4 root 5 units. Okay. 3.2, calculate the gradient of Sn. Okay, so gradient formula. So gradient of Sn, we know the gradient formula, everybody. We know it's y2 minus y1 over x2 minus x1. So in this case, y2, so 5 plus 3 over 4 plus 2 equals 8 over 6, which equals 4 over 3. Okay, and that is our gradient of Sn. 3.3, we are now working out the size of theta, the angle of inclination of Sn. So the formula for that, so tan of theta equals gradient of Sn. Okay, so therefore theta is going to equal shift tan of my gradient of Sn, which is 4 over 3, which is going to give me shift tan of 4 over 3, and that's 53.13 degrees. Okay, fantastic. That's something that I would actually put in my drawing. So 53.13 degrees is my angle of inclination there. The other things we don't really need to. We can just see it on the side. 3.4, okay, is now working out the size of LNS. LNS. Now that is this angle over here, ladies and gentlemen. Okay, so I'm going to do my technique that I'd use with my students. And that is making a Cartesian plane on the point where the angle is happening. So in this case, LNS, the angle is happening at N. So what I do is I draw a mini Cartesian plane on point S. And what I do is I zoom into that and I draw that here on the side of my page. So here's my axes. And this is my point N. And then this line is going through to S, and this line here is going through to L. Now I know I just need to work with this angle. Well, that's the angle I'm trying to solve for. Now, with me doing this technique, guys, is you actually isolating what you actually need to answer this question instead of worrying about the rest of the drawing. So now it's easy for me to see that if I work out this angle of inclination and I work out this angle of inclination, and I minus them from each other, it's going to give me the angle I need to work out. So the two gradients in question here is going to be, I need the gradient of NS or SN, which is what I worked out before, and that's 4 over 3, and I need the gradient of LN, which is going to be y2, so minus 3 minus 1 over minus 2 plus 4. And that's going to give me minus 4 over 2, which is going to give me minus 2. Okay, so that's my gradients. Now, why did I need the gradients? Because I need the gradients for the formula of angle of inclination, don't I? So for theta, let's make it color-coded. So for the red theta, I'm going to have to do angle of inclination formula for tan of theta is equal to -2. Therefore, theta for the red angle on my drawing is going to equal shift tan of -2, and then you get -63. I'm going to put this step in, but you're going to plus 180 to that because it's an obtuse angle. And you get 116,57 degrees. Okay, so now I've worked out that my red angle is 116,57 degrees. I already know what my red and my green angle is. That's 53,13. I worked it out earlier. So if I'm trying to solve for this question, the angle of LNS, therefore LNS equals 116,57 minus my 53,13, and that is going to give me 63,44. Okay, so the technique of extracting it out of your drawing makes it a lot easier to see which angle of inclination you need, and then we go from there. Okay, I hope that technique helps you. It has helped all my students in the past, so yes, please draw your mini Cartesian plane on where the angle is taking place, and then extract that piece of drawing so that you can see what angles you are physically getting when you work out your angle of inclination. Okay, cool. Let's move on to 3.5. Determine the equation of the line which passes through L. Okay, so 3.5, we've got it passes through L and is parallel to Sn. Write your answer in the form of y equals mx plus c. Okay, so equation passes through L. So let's draw it in just so that we have a better idea. Passes through L and is parallel to Sn. So let's see something. Oops, we don't want to draw a box. Let's make it a line. And it's going to be something like that. I'm going to rectify it now. Let's do that. Let's do that. Okay, so I've put that line in just so that we can visually see it and understand it, but it had to be parallel to that, and it had to be going through L. So what do we know about parallel lines, ladies and gentlemen? We know that parallel lines have the same gradients. So immediately for this equation of this line, we know that it's got a gradient of, what was Sn's gradient? 4 over 3. So 4 over 3x plus c, and then we know it's going through L, so we can sub in L minus 4 and 1, and then we can solve for c. So it's going to be 1 equals 4 over 3 times minus 4 plus c, therefore 1 equals minus 16 over 3 plus c, therefore we can bring that over, and it becomes a positive, so 1 plus 16 over 3 equals c, therefore 19 over 3 equals c, therefore y is equal to 4 over 3x plus 19 over 3, and that is my answer for the equation of that line. Great, nothing too difficult there. Now we can do 3.6, so 3.6 is asking us for, calculate the area of LSN. Okay. Great, so LSN's area, it is a triangle, so we know area of a triangle equals half base times perpendicular height. Okay, so yes, we do have our base, in this case LS, we've got, let's put it down, LS, we worked out in the first question, LS equals 4 root 5 units. Okay, and we just need Ln. Okay, so therefore, first thing we have to do here, Ln equals the square root of x2 minus x1, so minus 2 plus 4 squared, plus minus 3 minus 1 squared. Let's put that in our calculator and see what we get. And the calculator gives us 2 root 5 units. Okay, so therefore the area area of triangle LSN equals half my base, which in this case is the 4 root 5, times by 2 root 5, which is going to equal 4 times 5 is 20 units squared. Okay. And that is the answer to 3.6. Cool. Then it says 3.7, calculate the coordinates of P, which is equidistance from L, S, and N. Okay, so we've got equidistances going here. Let's have a look-see. Equidistance means exactly what it stands for, equal distances from certain points. So that means that from L to P is the same distance, so let's write that out. So we now know for 3.7, and we'll do that one over here. We know that L to P is the same as S to P, which is the same as N to P. That's what equidistance actually means. So it means that we can actually make distance formulas and then solve. We don't know what P is, so let's let P be A and B. We don't know what it is. So let's say, cool, let's use the distance formulas and then get two equations in terms of A and B and solve for them simultaneously. Let's do that. So LS, okay, so let's do LP equals SP. Or let's actually do these two because I can see them in my drawing. Doesn't really matter. So let's do those ones and those ones. Okay. So the first equation that we're going to be doing is LP. So we're going to say square root distance. So LP equals square root of, let's say, A plus 4 squared plus B minus 1 squared, okay? And then NP's distance is going to be, again, A, and we're going to say plus 2 squared plus B plus 3 squared. Okay, and that is our first equation, okay? Let's write that out. So therefore, square root, and if we times this all out, this is what we're going to get. LP, or we can make them equal because they're equal distances. So square root of A plus 4 squared plus B minus 1 squared equals square root of A plus 2 squared plus B plus 3 squared. Squares fall away, okay, or square roots fall away because you can square both sides. I'm just going to show you that. So if you square this side, you can square that side, and then we can sub in. So therefore, A squared plus 4A, or 8A, should I say, plus 16 plus B squared minus 2B plus 1 equals A squared plus 4A plus 4 plus B squared plus 6b plus 9. Okay, so what's going to happen to the squareds? That and that will cancel with that, and then it's a matter of getting your b's on one side. So let's see. So we've got, therefore, 8a minus 4a minus 2b minus 6b equals 4 plus 9 minus 16 minus 1. Okay, and then we're going to say 4a minus 8b equals 4 plus 9 is 13 minus 16 is minus 3 minus 1 is minus 4. And that is your first equation. Okay, nothing hard about that, but you can see that this is going to be lengthy, but it's not difficult. It's just more tedious. Okay, we're going to continue with this. So the next one we're going to do to create the next equation is, let's do SP equals NP. Okay, so let's do SP quickly here. SP is equal to the square root of, again, A. What is S's coordinate? S's coordinate is 4 and 5. Okay, so A minus 4 squared plus B minus 5 squared. Okay, and we will then make them equal to each other. So let's have a look. So we're going to say SP equals NP. So NP is that. So we're going to say, therefore, square root of A minus 4 squared plus B minus 5 squared equals NP, which is A plus 2 squared plus B plus 3 squared. Therefore, squaring both sides again, those cancel. And that's going to give you, again, this is going to be, so I'm going to times it out. So it's square roots are cancelled. So we're going to have A squared minus 8A plus 16 plus B squared minus 10B plus 25 equals A squared. You can just copy this from the previous one. Plus 4 plus B squared plus 6B plus 9. Okay, again, the A squareds and the B squareds will cancel. And let's bring everything over. So we've got minus 8A minus 4A minus 10B minus 6B equals 4 plus 9 minus 16 minus 25. Therefore, minus 12A minus 16B equals 4 plus 9, which is 13, minus 16 is minus 3 minus 28. Okay, and that is my second equation in terms of A and B. Here we have a scenario where we can actually use elimination method instead of substitution. Substitution would be too complicated here, guys, because in order to get A or B by itself with this simultaneous method, it will make fractions, the substitution method. So let's times this whole equation by 2. And the reason for that is now you've created a new equation. 8A minus 16B equals minus 8. So now if I take this new number 1 and I minus it from number 2, let's see what happens. 2 minus my new number 1. Will it get rid of a variable? Yes, it will. Okay, so let's say my answer is, now it's just column minusing or subtracting. So it's going to be minus 12A minus 16B equals minus 28 minus 8A minus 16B equals minus 8. So minus 12A minus 8A is minus 20A. Minus 16B minus 16B cancels. And then minus 28 plus 8 is minus 20. And then you can just divide both sides by minus 20. A is equal to 1. And then it's as simple as subbing in A into one of the other equations. So let's sub A equals 1 into equation 1. You can do the original one or the new one that you've made. Doesn't really matter. So therefore, 4 times 1 minus 8b equals minus 4. Therefore, 4 minus 8b equals minus 4. Therefore, minus 8b equals minus 8. B is equal to 1. Okay, so therefore, P is 1 and 1. That is the coordinate. You've worked it out simultaneously. Quite a lot of marks, or quite a lot for 3 marks, right? But it wasn't hard work. It was more just a lot of algebra. Now, there was another way that you could go about this question. Now, what you could have seen is, simultaneously, a lot of people would have seen that first. But if we're looking at our drawing here, do we notice that, say, for example, I put this into a circle. Say, for example, I put this into a circle. What do we know? We know that this would be a diameter. Do you agree? So this would be the center of the circle. Now, that and that would be equal because they're both radii. And if I draw a line from there to there, let's say, for example, this is our P, the center of the circle. Do you agree with me that those are all radii? So this was actually a clever move because drawing a circle around it, making it cyclic, told me that because this is 90 degrees, we now know that this is a diameter. Why? Because of angles in a semicircle. Well, converse theorem, angles in a semicircle, right? And what does that tell us? Well, if that is the center, if P is the center, it means that PS, PN, and PL are all radii, which means they're all equal, which means their distances are all equal. Do you see that? So that was another way that you could go about it. And how you would work that out? Well, because we know that SN is a diameter, surely we know that P is now going to be the center. So you could have just done midpoint. Okay. So I'm going to extract that as another option. I feel like a lot of people would have also known to do the simultaneous way, but I'm just going to extract that and do it as a separate answer. So I'm going to take the drawing out here. I'm going to do that. And I'll say here, just another option for 3.7. Okay. So 3.7, the other option was to see that there was a circle. So we call it cyclic. So we made it cyclic. So there, all these corners of my triangle were touching the circle. And we could then assume, because we've made it cyclic, that that is the diameter. Okay, so what we would say there, and then that means that the center of the diameter would then be our P value, because that, and then that is a radius. So I'm just going to write it out here. So we could say that SN equals a diameter, reason being converse angles in semicircle. Therefore, P is the center of circle. Reason, because PL is equal to PS, which is equal to PN, the equidistances. Okay, so then you would just work out therefore midpoint of SN is going to equal your P coordinate, right? Which in this case is going to be x1 plus x2, so 4 minus 2 over 2, and 5 minus 3 over 2, which is going to give you 1 is to 1. So that was another way of doing 3.7. Okay, so that was quite a lot easier, but much more difficult to see, because now you're including Euclidean geometry into your analytical geometry. And then the last question, everybody, calculate the size of LPS. Okay, so 3.7, let's just carry on from this one. LPS is this angle over here. So let's just zoom in on 3.7. LPS is this angle over here. Okay, and what we would need there is we would need angles of inclination. So I'm going to extract a separate drawing for that one. So I'm going to say, cool, let's take this out. We now know what our angle is. Let's go here. Question 3.8. The angle of LPS. That's what we're trying to solve for. Okay. And then we would say, cool, we now know what our P value is. Our P is 1 and 1. So that ended up being on this graph, P1 and 1. That's not nicely drawn. Let me draw it a bit smaller. P1 and 1. Okay, fantastic. Now, we know, remember what I told you, if you want to work out an angle, all we need is a mini Cartesian plane on where the angle is happening, okay, which is here. So what we would do, we would extract it. So we would take here and we would say, cool, this is going to be my LP. Do you agree with me that L and P share the same Y value, which means that it is horizontally straight? So that is going to be there. And so this is P, and then this is going to go up to S, and this is L. And I'm looking for this angle. I know S is 4 and 5. I know P is 1 and 1 now. We've solved that in the previous question. And we know that L is minus 4 and 1. Okay, so all I need basically is this angle of inclination, and then I'm just going to minus it from 180. So therefore, SP, the fact that SP is on SN, so the gradient of SP is the same as the gradient of SN. If you didn't pick that up, it's very much easy to just work out the gradient of SP, but the gradient there is 4 over 3. Therefore, angle of inclination, which we know already, is 53. So the gradient of SP, sorry, the angle of inclination of SP is equal to 53,13. Therefore, LPS is equal to 180 minus 53,13, which equals 126,87 degrees. Okay, so not too much. Everything at the end of the day did work out. So that was just another angle of inclination question. Okay, question 3, quite a mouthful, quite big. Lots of marks, a little bit more complicated than the usual analytical geometry. But yes, awesome. Question 3 complete.